Now that we've defined the notation, let's go back to our decision boundary example and look at the impact of those coefficients that we learned on the actual decision boundary that we obtain. So in the example that we had, the score was defined by 1.0 times awesome minus 1.5 times awfuls. That means that W1 was 1.0, W2 was minus 1.5. And here W0 was 0. I didn't even show that 0 there, but it was kind of equivalent to saying W0 is 0. And that's how we got the decision boundary where the score below the line was greater than 0 and the score above the line was less than 0. And that's what made our predictions be positive on one side and negative on the other. Now, let's say that instead I had learned that the coefficient W0 was 1.0 instead of 0. What does that mean? That means that our score function now has this extra term, 1.0 plus 1.0 times awesome minus 1.5 times awful. So what happens to the line, to that decision boundary? Well, that line gets shifted up. And so if you look at that point on the lower left, which is close to 0.0, which before we predicted as being a negative review, after we make that change, we now predict it to be a positive review. So it turns from orange to blue. On the other hand, if you take the coefficient of awful, which is now minus 1.5, and we increase it, we say it's minus 3.0, so awfuls are just really awful. What happens to our equation? Well, the minus 1.5 gets replaced by minus 3.0, so it becomes 1.0 plus 1.0 number of awesomes minus 3 times number of awfuls, and that curve tilts down a little bit. So if you look at that blue point that was on the positive prediction side, it gets shifted to the other side of the decision boundary and it turns from orange, so blue to orange. And that's because you had two awfuls in it, and awfuls are just awfuls. And before they were counterbalanced by the 4 awesomes in that data point, but now the 4 awesomes can't counterbalance the 2 awfuls.